Welcome to my second talk of the day. Fun is just beginning. So today, this talk is about Spring Boot. So we're stepping away from the Grails stuff and how we can go about making Spring Boot, which is already great by itself, even Groovier with adding sprinkles of groovy magic all over the place. And in this talk, I'm going to take you through the various steps needed to become completely groovified when using Spring Boot. And so it should be fairly interesting. So on the agenda, we'll talk a little bit about Spring Boot and Groovy. And we'll add a little bit of Groovy to our Spring Boot app. Then we're going to go completely nuts with Groovy and our Spring Boot add it all over the place. We'll cover testing with Groovy, have time for questions. So it should be kind of fun. OK, so Spring Boot and Groovy. So one thing to point out is that Spring Boot is not dependent on Groovy, of course. It's completely built independently of Groovy itself by design, but that it already has Groovy as part of its features. So that, all those cool, like this is a Spring Boot controller in a tweet, and this is like all those cool little demos all done in Groovy. Yeah, Groovy has helped enable that. The little scripts and the Spring Boot CLI piece of Spring Boot is very much tied into the whole Groovy ecosystem. It uses some particularly interesting features of Groovy. One of them is grab, so to pull in dependencies and so on, and using the Spring IO bombs and so forth. The @grab annotation is able to pull in dependencies, which then gets wired into creating a Spring Boot application by Spring Boot's auto configuration part. Spring Boot has various Groovy components, I guess you could call them, or parts of it that use Groovy. As I said, the Spring Boot CLI is essentially a mechanism for running Groovy scripts, and it has extensively uses Groovy AST transformations to basically automatically enhance. So when you write a Spring Boot microservice as a Groovy script, you don't have to import all of the Spring stereotype annotations, @REST controller, @component, those are just automatically imported by the Spring Boot CLI. It also does some interesting magic with AST transforms, so that if you declare, I don't know, an annotation on @entity for like Java persistence, it'll automatically configure JPA. So based on the code that you have in your Groovy scripts, Spring Boot is doing some auto wiring or auto transformation of your code to make it simpler. So Spring Boot already has all these Groovy components, and that's the key thing. So they're already there at your fingertips. Whether you choose to use them is up to you. Another interesting feature which was recently added is Spring Groovy is the Groovy template support. So Groovy has, as of Groovy 2.3, a new template engine, which is a kind of markup builder style template engine, which has support for layouts and templates, and is type checked and expressive, and that can be easily added to any Spring Boot app, and I'll talk about that in a moment. And of course, Spring Boot auto configure, as I said, it has various AST transforms as part of that project, which make it especially elegant to use Groovy and Spring Boot together. So, as I said, Spring Boot microservices, whenever they are shown in slides and so on and so forth, they're generally shown with Groovy code because it just makes it so much shorter. That famous 140 character Spring Boot tweet, "This is a runnable app," is all expressed in Groovy code, and that Groovy itself allows you to express things in terms of your Spring Boot controllers and so on in a far more expressive and concise manner than Java code does. Why is that? Well, because you can emit things in Groovy. So you can see just in this example here, if this was in Java code, we would have to have declared the class as being public. So we need the public operator. We would have to have declared the home method as being public, because the default scope in Java is package protected for some bizarre reason. So those would both need to be public. We would need a whole bunch of semicolons. Actually, no, I think we only need one in this case, so not a whole bunch. But we would need a semicolon in there. I would need an explicit return statement. Yeah, so you need that to add that. And yeah, there would be a whole bunch of extra ceremony, and that's just in the small example. As you get in more, complex examples of Java code, it always tends to be more verbose than Groovy. But we already know that, I'm sure. So let's talk about how, if you're not approaching Spring Boot from the CLI, which a lot of people, I think, are not, how do you go about adding Groovy to Spring Boot? Because the Spring Boot CLI part is interesting and fun from a kind of demo, prototyping perspective, to write little Groovy scripts and so on. And maybe, there may be cases where folks are happy to push those scripts into as production applications, full production applications. But I think a lot of people are approaching Spring Boot from a traditional Java style project. So creating a pom.xml, creating a build.gradle, and starting with a traditional style project and building it from there. So how do we introduce Groovy in that sense? Because if you just use Spring Boot by default, there's no, as I said, there's no requirement to use Groovy. You can just build with Java, build everything with Java. There's no requirement to use Groovy. And this talk is really about encouraging you folks to see the benefit of using Groovy in your Spring Boot applications. So we're going to go through this path to enlightenment, I call it, in using Groovy. And we'll start off slow, so Gradle for the build, that's your first dose of Groovy. So if you're using Maven, just chuck that up, put Gradle in there, much better. You've already got some Groovy in as part of your build system. So that's one way that you can start getting a taster of Groovy without necessarily introducing it into your production code if you're not ready or your organization is not ready. Some organizations are not ready to do that. Or not willing to do that immediately. We see that all the time, strange as it may seem in this day and age with Groovy being 10 years old or whatever. There's still organizations very conservative. So how do you sneak Groovy in there? And a good starting point is the build system. Yeah, so we start with the build, and we get Groovy into the build system via Gradle. And another good area to start in is unit testing. Yeah, so unit testing is not production code, right? It's your tests. Folks on your team can start using Groovy and playing with the language in a unit testing context, which is a great way to familiarize yourself with a new language, right? If you've never used Groovy before, or your team has never used Groovy before, they can use it to write their unit tests and test Java code, yeah? You don't have to write unit tests that test Groovy code. Groovy can test Java code, yeah? So that's how we're going to start slow. And then you can start digging deeper into really embracing Groovy throughout your Spring Boot code base. So actually replacing your production code elements in a Spring Boot application with Groovy code instead of Java. And there's a number of places we can do that, and we're going to dig into that. So, Groovy controllers, Spring MVC controllers, that is, writing your production code in Groovy. Groovy templates, using the Groovy template engine to declare your views and layouts. And then once you've completely taken, which one was the right one, the blue or the red pill? I can never remember. Anyway, you've convinced the organization, this is like now Groovy, you're going to go Groovy all the way, and you can start embracing some of the products of the Grails ecosystem, but inside Spring Boot. Yeah. So things like GORM, things like GSP. So we're going to see how we're going to be able to do that. Okay, so step one, adding a powerful build system to your Spring Boot application. So this is actually so trivial, I'm not going to spend very much time on this, and this talk is not necessarily about Gradle itself, or who uses Gradle in this audience, by the way? That's a lot of hands. Who uses Maven instead? A few hands, okay. So yeah, I'm not going to, you all guys are all familiar with Gradle, and I'm not going to go into a huge amount of detail this, but for those of you in the audience who are not, Gradle is a flexible, powerful build tool. So it's not actually, Gradle is not like, it shouldn't be seen as something that is written in Groovy or designed only for Groovy. It's essentially a Groovy DSL, the way you express your build, but actually the core of Gradle is actually all written in Java, and you can use Gradle to build Java apps, you can use Gradle to build Scala apps, you can use Gradle to build C++ apps. It's a general purpose build tool, and it has, for me personally, the most momentum in terms of innovation in the build space in the Java ecosystem. So there's a lot of innovation going into Gradle, particularly with a interesting commercial entity behind it and so on. It's well documented. And interestingly, recently it was announced that Google would be using it as the build system for Android. So it has a lot of, and that's a subjective opinion, better than Maven. Personally, yes, but others will disagree. So I feel, but yeah, it is. It's a great build tool, and it's extremely well documented. So you should check out the documentation there. So why would you choose Gradle and instead of, or rather than stick with your good old Maven POMs and just forget about just stay on that path? Well. Builds are not static. So one of the issues with that encountered with Maven prior to finding Gradle is that Maven has this belief that a build system is a statically declared thing in an XML file, and that you shouldn't be able to change it very much. And there's ways to change Maven builds through its phases and goals, but as soon as you end up having to write Maven plugins and script any kind of Maven thing, it starts to get horrendously complicated. It's not designed. It's designed to be used the same way for every build, and that's it. It's not designed for you to extend it and change it. And yeah, if you're going to build, if your projects all build the same way and all, that may be fine. And a lot of people are very happy with Maven. But if your build in any way diverts from the norm, which in my experience with builds happens quite often, then it can be challenging. And that's where Gradle is great, because you have this flexibility. It has a really easy plugin model that's really easy to extend. I had the pleasure of developing the Maven plugin for Grails. It's a plugin for Maven, so you can run Grails inside Maven, and it's writing Maven plugins is non-trivial basically in comparison to Gradle. It has the Groovy scripting support, and yeah, it's just a constantly innovating area in Gradle, and I highly recommend you check it out if you don't already. So in terms of adding. And as I said, I'm not going to spend a lot of time on this. But basically, you rm space pom.xml, and and you add a file called build.gradle, and this will power your Spring Boot build instead of Maven. And if you want your, so if you're going to stick with pure Java, you apply just the Java plugin, or if you're going to include Groovy in your code base, you use the Groovy plugin, you add Spring Boot, and depending whether you are needing any kind of IDE support, you can add various other plugins and so forth. But you configure Spring Boot in the standard way using your Gradle build script, and then Gradle itself is pretty self-explanatory. If you want to know what's available, Gradle space tasks, and that'll give you a list of known Gradle tasks that are runnable. So some of them are added by Spring Boot, but the common ones are assemble, which will build your wall, run, which will run your boot application, clean to clean it out, and so on and so forth. You can use dependencies to get an overview of a graph and so on and so forth. But yeah, I'm sure you guys have experience with this, so I'm not going to spend a huge amount of time on this particular demo. So yeah, to get going with Gradle and add your first dose of Groovy into your Spring Boot codebase, just add a build.gradle, add to the path the Spring Boot startup POMs, and that's it. Okay, now step 2 on the path to enlightenment is Spock, yeah? So who has used Spock? Lots of hands. Excellent. Who hasn't used Spock? A few hands. Okay, so Spock, for those of you who don't know what Spock is a is a test and specification framework, yeah? So it's again based on another Groovy DSL. It's well documented. In fact, the latest documentation is fantastic. It's powerful and intuitive, so it's a way to create really readable tests, and it supports data-driven tests. And generally, it's superior to JUnit. We've standardized on Spock across everything, and it's a great toolkit. So why would you choose Spock? As I said, it's got the data-driven tests, integrated mocking and stubbing, and power assertions, which are just fantastic. So when you get an assertion error in your tests, JUnit, for example, has all sorts of methods and extra methods, assert equals, assert this, assert that, all sorts of method signatures inside you have to static import to compensate for the fact that the diagnosis on the error is not very clear. Whilst in Spock, it has integrated support for power asserts, so you just say x equals that, and you get a detailed diagnostic of why that failed. So you can see what the value was of x, you can see what the other value is in your code, detailed diagnostic. It's far more readable without adding extra ceremony, extra methods, as you have to do in JUnit. So how do we add Spock? So basically, essentially what you have to do is add to your build.gradle a dependency on Spock, which I have done over here. There it is. Yeah. So we have the Spock dependency in place. Then your Spock tests simply go in your test Groovy directory, and you tend to end them with spec. And the Spock test itself extends Spock.lambda specification. And the great thing about Spock is, the integrated support for, in this example, I'm mocking a static method call that's interacting with GORM in this case. And you can see that, you can create very readable test names, very descriptive. So here I've got, it says that test that the list action renders the list view with the correct model. And it's saying, given a person controller instance, and here's my test data, when the list action is called, the model in view is correct. So you create very readable tests, very expressive tests that, the worst thing when taking over a code base that you have to maintain is, the worst thing of taking over a code base that you have to maintain is it doesn't have any tests. The second worst thing that is taking over a code you have to maintain is it has tests that make absolutely no sense when you read them. And this is what Spock really helps in this area. And you also get these data-driven tests. So here we got a hello action. So it just essentially, if you look at the person controller here, it just essentially returns a message saying hello, somebody. And this one, we're passing it in some data. So when the name is John and when the name is Fred, the greeting should be hello John, hello Fred. And you can see that we can use this data to drive the test. So it'll iterate over each data item and test that those outputs are consistent. Yeah. And there's a whole bunch of other features that Spock support. Again, I'm not going to, this is not a Spock talk, so I'm not going to go into that in a huge amount of detail. But Spock is hugely powerful. It has things like the unroll annotation, which is just amazing when you see it in action. And worth going to a Spock talk if there is one at the conference. Definitely a compelling framework. Okay, so yeah, to get going with Spock, and as I said, this is like the starting with in terms of getting Groovy into Java projects and so on. This is a good place to start because you start with the unit tests, you start with the build. They're not touching production code, and you get people into Groovy. If you've got large Java teams, you get people into Groovy without forcing it on them right into a production scenario, which some folks may be uncomfortable with if they've not used Groovy before. So yeah, you just extend Spock specification, create a spec, write your specs, and yeah. So now we get into, you've gotten Spock, you've gotten Groovy into your organization via your build.gradle and your Spock specs. So how do we now, so we've convinced people that this Groovy stuff is great. Now we're ready to take the step and add Groovy to the rest of your code base. So, and actually that's completely a trivial thing to do. Fundamentally, Groovy and Java can be mixed seamlessly in a Spring Boot build. With a joint compilation, you can have code written in Groovy, code written in Java, cross-referencing each other, and everything just works. Yeah, that's been the way of Groovy for years. I mean, I remember the first integrations that Spring did with Groovy was like they had like a script element in the application context XML, and it's kind of treating Groovy like as an external thing. That a bit like Ruby or Python, where you kind of run these external scripts that that shouldn't be near the job. But really, that's not how Groovy is used in most scenarios. Most scenarios, you compile Groovy and Java together, and it's perfectly natural to have some part of your code written in Groovy and some part written in Java. The interop between the two languages is completely seamless in most cases, and unlike other languages on the JVM, which have trouble. And the other thing is that Groovy has compile static now, which is a great thing for when you have resistant. A lot of Java folks, they really they argue the fact that Java is far more performant and Groovy, and they're not going to write this stuff in Groovy because the performance is not going to be good, and they don't want to write it in Groovy because they're going to lose out on their type checking, and they want their compiler to give them errors, and they want their IDE to tell them when things go wrong, and they don't leave the IDE, they've never opened Vi, etc. So you get folks that are very much Java folks who very much insist on everything being statically compiled. And there is no way to convince those folks in a lot of scenarios. But now there is. So if you can standardize this one across the team, you can add compile static to all your Groovy code. It gets compiled down to bytecode in a very similar fashion. There's various performance comparisons out there online you can go and check out. But essentially, the performance difference between Java and Groovy with compile static is basically 0. And you get the type checking. So when there's that horrible you don't get those horrible missing property exceptions and missing method exceptions at runtime that Java devs don't like very much. And it was an unexpected experience for them to not get a compilation error when referencing a method that doesn't exist or referencing a property. So it's much easier in the sense to then introduce Groovy into a Java team because you get the familiarity, and with the tooling being so good now as well, that is something that's really come a long way in the last 5 years. So kudos to the GGTS, Groovy Grails tool suite team on the Eclipse side and the IntelliJ guys from JetBrains who have done phenomenal work making Groovy so great to work with in modern IDEs. So it really has come a long way. And you can refactor and rename and move, and things just work. So introducing Groovy into your code base is easier than ever. And that can only be a good thing. So why would you use Groovy? Why? And how would you convince people in your organization? So Java 8 has lambdas, which is great, but you need Java 8, right? You need a production Java 8 installation to deploy to. You need your production environments to be Java 8. And so how many people are running Java 8 in production? One hand? You're running Java 8 in production? Oh, good job. So there's like 2 people in the room running Java 8 in production, right? So that's so the whole Java 8 lambdas, that's great, but until people actually have Java 8 systems and production servers, it's still quite a way off for a lot of people. And right now you can run Groovy on any JVM and you get lambdas, in this case Groovy closures. You get the Groovy JDK, which is full of useful methods, all those methods that they added in Java 8 with slightly different names or whatever, but they're all there in Groovy. The Groovy JDK is mature. It's been around for years. It's battle proven, and it's deployable to any JVM right now without having to wait for your production systems to be Java 8 ready. Groovy is also easy to learn for Java developers. So you've got, especially now with compile static making it even easier, the syntax is very similar to Java in the case of Groovy. And you have this, as I said, static and dynamic compilation. And you can also argue the fact that there's now Android support. So Android is all the rage. And Groovy in 2.4, which is in beta 2 at the moment, runs on Android, and runs well on Android. It runs so well, in fact, that as I mentioned in the keynote, that you have folks from the New York Times already using it for their production Android applications. And yeah, the extensive Groovy JDK, which I mentioned, so SDK, and the continually maturing docs. So it's a great time to pick up Groovy, better time than ever. So yeah. So here I have an example of a Spring Boot app, and you can see that I've applied the Groovy plugin, and instead of source main Java, I have a source main Groovy directory. A lot of people sometimes get confused. Well, do I have to only put Groovy code in there? Well, actually, you can put Groovy and Java code in the source main Groovy directory. So you can put, and it will be compiled all together. So if you want to continue to write parts of your application in Java, write parts of your application in Groovy, you can continue to do that. And you can see in here that my Spring Boot application is completely written in Groovy. So I've got an application class, and it gets run as so this is my main Bootstrap class. I've got a controller here which renders the home view. This is all using Spring MVC standard annotations, but instead, as you can see by the the revealing def keyword that it's all done in Groovy, returning a model in view, and with the various status information. So as you can see, this is an application that's completely written in Groovy, and we can run it. There we go. So we're using Groovy Spring Boot 1.1. Okay, so introducing writing your Spring Boot application in Groovy is not a big step that requires massive effort. You just and as you can see, Groovy code in comparison to Java code is a completely readable experience. And if you want to add type checking to any Groovy class, as I mentioned before, all you do is you import Grails, sorry, not Grails. Too many Grails talks. Groovy.transform, and you add @compile static. Job done. Yeah, and this will statically compile. No, fine. Okay. Okay, so what is the step to be taken? Well, there isn't much effort required. You just switch languages, you create your classes in Groovy with .groovy instead of .java, and you reference all the same Spring Boot APIs, @REST controller, @request mapping. As you get familiar with the language, you can start to take advantage of things that Groovy allows. So you might initially be tempted to write public on the front of all your method signatures, or add return keywords. You may be tempted to use the for loop instead of each with a closure, or you might, there's various things that Java-isms that you might begin with. But as you get familiar with the language, your Groovy will improve. So to get type checking, you just add compile static to your classes, and that'll compile your classes down to with direct method dispatch instead of dynamic dispatch, thus improving performance. Yeah. No. So compile static means to directly dispatch method calls. Yeah. So just like Java. So just like in Java, you can't do any kind of metaprogramming or anything like that. You can't do that. You can, however, mark like an approach that's good to take. So sorry, the question was just for the when you use compile static, can you use metaprogramming? So one approach you can take is to put compile static at the top of the class. Yeah. Then at the method level, if you have one particular method that needs dynamic behavior, any kind of dynamic dispatch, metaprogramming, use of builders, anything that doesn't work with static compilation, you annotate that one method with compile dynamic. Yeah? So that allows you to write the majority of your code with static compilation on and turn it off when you want to use a particularly dynamic Groovy feature, metaprogramming, anything that and that's an approach that I use quite often if you reach the point where you want to use a particular Groovy builder or a particular Groovy dynamic feature that doesn't support compile static, you just drop down, and that's it.
Can you still use like Groovy Spy outside of Spock tests?
So I'm not. So the question is, can you use Groovy Spy in your Spock tests? So I'm not sure if Spock actually supports compile static. That's a good question. I need the Spock team to answer that. But in the case of unit tests, I'm not sure why you would want to, what the benefit would be of statically compiling your unit tests.
I don't mean on the unit test, but if like your controller, you have compile static, and then you want the test to do some mocking.
Oh yeah, that works fine. Yeah, from Spock's perspective, it's exactly the same. Yeah, there's no difference. Okay. Okay, so you've now rewritten, thrown out your Java code, and you've rewritten your code base in Groovy, but you're still stuck with these JSP views, yeah, or I don't know, free marker or something like that, and you want to go full on Groovy down to the view layer. So how do we achieve that? So there's various options, and I'm going to talk to you about one of them first of all, which is fairly recent. So in Groovy 2.3, there is a new markup template engine, it's called. And it basically has support for type-safe views and layouts. And it's like a markup builder style thing, but it has native Spring Boot support. So in Spring Boot 1.1, the latest releases, there is native support for Groovy templates. So how do you get these Groovy templates and how do you get going with them? So all you do is you add the Groovy templates jar, because like Groovy, why is it keeping doing it? There you go. So Groovy was modularized quite significantly. So now the Groovy templates are not, if you're not using Groovy all, the Groovy templates jar is a separate thing that you can add as a dependency. And you add the Groovy templates jar to your build.gradle. And then all you have to do is essentially add templates. And templates are essentially files that end with .tpl, and you put them in source main templates. So I tend to take the approach of putting views, because Groovy templates have both views and layouts. So I like to put views in a subdirectory called views, and then layouts in a separate subdirectory called layouts. But the top level directory is source main templates, and that's where inside your Spring Boot app you put the templates. So I'm just going to do a demo, and this is a example shamelessly stolen from Cedric. We are on step 4. So in this example, we have another Spring Boot application. And you can see that we got a source main Groovy with my various controllers. And in the resources subfolder here, we've got our templates. Before I continue that, actually, I'm just going to point out the dependency that was added. So as you can see over here, we have a compile time dependency on Groovy templates, right? So we've added that. And under here, under my templates directory, as you can see, I've got the layouts and the views directories. And in the views, we've got a home template. And as you can see, this particular template is specifying that it wants to use a layout called main. So there's a layout in here called main.tpl. And this is essentially what Groovy, actually, let me, syntax. Yeah, that's better. Okay, so as you can see, it's a builder-style approach. So you got at the top here, I'm using yield and escape to output the doc type. But essentially, each method call becomes a resulting HTML tag. And of course, so you don't have to output HTML. You could be outputting XML or whatever you choose. You got the head tag here, the title of the page. The layout can reference the page title. You got a link to a style sheet, the body, various divs being created. Whenever you want to output some text on the body, you have to call the yield method. And then down here, you can see there's a call to main body, which applies the body of the page that the layout is being applied to. Yeah. So this is a layout. And then the home template specifies that it uses that layout. Yeah. So it's using that. It specifies the page title, which then gets output in the resulting content, and the main body. And the main body is defined using the contents method, and you can see it's got a div and so on. So if I run this application, oops, I'm just going to do a clean because it keeps switching branches. And okay. What have I done? I've done something. I'm going to revert. See if that changes. So there you go. That's rendering my my Groovy templates. And the other thing you can do is, so I've got another template here, is from the, say for example, in this example here, the list method of the person controller returns a model in view. And you can see that the view name is view/person/list, which then becomes my list.tpl file, yeah? And you can also see that I'm passing in a model, and you can see that I stole this from Cedric, who used persons instead of people. But, but yeah, I'm passing in a model variable called persons, and you can see then that you can reference that inside of your Groovy template. So and you can just use Groovy closer, so I can say persons.each person, and then output a list item inside of my unordered list with an anchor and so forth. So it all creates a very elegant syntax for outputting markup, and I'm sure you'll agree. Yeah? So that's, sorry, was there a question? No. Okay. So that's Groovy templates. So elegant, readable views expressed in Groovy. As I said, that example there with the unordered list, it's a perfect example of how with Groovy's closures and iteration, you can define expressive views, all written in Groovy code.
Can I ask a question?
Yeah.
Is everything by default HTML output encoded, or do you have to do something special to make it output encoded?
Yeah, so I think there is a, in the Groovy templates, there's an unescaped, I've forgotten. I think there is a mechanism to control the encoding, but it's not quite as advanced as GSP, which I'll talk about in a minute. Okay, so now you've introduced all these bits of Groovy. Now it's actually time to take to the next level and introduce some bits of Grails. And the first bit, which you may have seen hints of already, is to introduce GORM. So what is GORM? Yeah, GORM is, oops, what happened there? So GORM is a powerful, well, it used to be just for Hibernate, but it's really a multi-data store query layer. So who's used GORM here? A few hands, yeah, good. So you get, all great features, dynamic finders, criteria, persistence methods, integrated validation, automatic mapping of entities to an underlying data store, and easy access to the underlying native APIs. So there are GORM implementations, stable, released implementations for Hibernate, for MongoDB, for Cassandra, for Redis, and I left it off the list because I ran out of space. Neo4j as well. So it really is multi-data store right now. And the most popular ones at the moment are Hibernate and MongoDB, I would say. That's the ones we see the most usage of. Who uses MongoDB here? Quite a few, yeah. OK, so the GORM for MongoDB stuff is at version 3 now, so it's come a long way. And of course, the Hibernate one is historically the oldest one. So how do you go about adding GORM to a Spring Boot application? So it's quite trivial. All you do is in your build.gradle, you add a dependency on the GORM Hibernate for Spring Boot jar. Yeah. So you declare that dependency, and then because Spring Boot doesn't have conventions for a directory structure like Grails does, so there's no Grails app / domain directory. So Grails can't. So it can't know exactly what is an entity. So each GORM entity you have to annotate with grails.persistence.entity, yeah, in your application. And so let's have a look at that in action then. OK, so if I open up my person, you can see that I have a person.groovy, and it's annotated with grails.persistence.entity. And just by doing that, it essentially will, Spring Boot will detect this class and treat it as a GORM entity. Yeah? So you don't need to do anything else. Now, in order to configure the underlying data source, you can create a application.yaml file or an application.properties file. And that allows you to configure your Hibernate properties, so the data source connection and where it is and so forth. That works exactly the same as it does in a normal Spring Boot application. Yeah? The data source configuration is exactly the same. You just configure your data source, and GORM will pick that up. Once you have an entity in there, and let me just point out that dependency I added in here. So as you can see, I've actually got MongoDB in here. But anyway, that was part of the next demo. Let's just change it. There. OK, so I've added org.grails.gorm.hibernate4, gorm-hibernate4 Spring Boot. I need to check if that version is right. Yes, that is the latest version. OK, so I've added that as a dependency and created my entity domain class. And if we look at my person controller, we can see that when I implement my Spring Boot controllers, that I can just use the GORM API. So I can call get and get hold of the ID. If it's in case of an update, I can call the save method. In this case, I'm using with to populate the object. And if there's no ID, I can just save the entity, which will get passed automatically as a populated model. So you can write Spring MVC controllers, and if you wanted, you can create repositories that are annotated with @transactional. So just normal classes that are beans that are annotated with @transactional, have those wired up and create transactions and so forth. In this case, I'm doing it in the controller. You don't have to do that. You can create your separate repository classes in your Spring Boot application, add transactions. An alternative is to use the person.with transaction method and wrap it in a transaction that way. GORM has a with transaction method that you can pass a closure in and wraps it in a transaction. But I would recommend basically, instead of doing that, to delegate to a separate repository class, as is better practice. But anyway, you can see that I'm using GORM within my controller here. And if I run this, as you can see that without having to do anything, Spring Boot's auto configuration support automatically detect my person entity. And as you can see from the logging output here, I hope you can see anyway, that Hibernate kicked in, and it began using an embedded database factory, so it's using H2. The reason it's using H2 is because I think I have an H2 dependency. Yes, so I have an H2 dependency here. That's why it's using H2, but that's the same as a normal Spring Boot application. If I had MySQL in there, it would use MySQL. So it creates a embedded database factory, sets up Hibernate, configures my entity, and I have GORM all set up. So now if I go to person.list, I can come in here, create people, and it's using GORM for persistence.
You get data validation too?
Yeah, so you can declare your validation just like in a normal so I just create a static mapping equals, static constraints. Mapping works as well, but it's for a different thing. So you can say blank, that shouldn't be blank, and last name should be size between, I don't know, 5 and 50, whatever validation constraints you want, you can put in there. And basically, this is just a very simple example, but obviously you would do something like if person.validate, then go ahead and do this. Otherwise, else return the edit view again, or redirect edits and store it in Flash, or do whatever it is that you're going to do to handle the validation error.
Can you find all the relationship, just like company, stuff?
Yep, absolutely, all the relationships. It is GORM from Grails. Yeah.
What's the use of add entity one more time?
So in Grails, we have a Grails app / domain directory. So we're able to say, okay, everything in that directory is a domain class. There's no need to define an entity. But in Spring Boot, because there's no conventions, everything goes in source main Groovy, you have to be explicit about this is an @entity, this is an @controller, this is an @rest controller. They use annotation stereotypes to mark things as what they are, rather than directories like we have done historically in Grails. Yeah, that's why you need to put the @entity there. Otherwise, it wouldn't need to be there. If the @entity wasn't there, it wouldn't know what to do. It would just be a pogo, nothing class. Do dynamic finders still work? Not with @compile static, but with @Grails compile static, it will.
We do @Grails compile static?
Yes, yes. Yes, it works as well. Yeah, it's one of the dependencies that gets pulled in. And as this is GORM, you can do whatever dynamic finders and where queries. The full GORM API works, within Spring Boot. Okay. So how are we doing for time? Okay, that's good. I'm just going to stop that a minute. So it's GORM for Hibernate. It's trivial to create entities in a boot application. You just declare a class as being an @entity. Don't get confused with javax.persistence.entity. It's grails.persistence.entity. If you use javax.persistence.entity, boot will configure a separate thing, JPA, container, all the other business, which is not what you want. So you want a grails.persistence.entity. So why would you use GORM? Why don't you just use Spring Data? Well, GORM has huge, other than dynamic finders and everything, it has hugely powerful query composition and detached criteria. So this is just a recent example that I gave in my talk earlier from a new feature in Grails 2.4, where you can actually, using where queries, you can compose queries using GORM. So in this example, I'm creating an employees query. So that employees, say it's saying employees.where the region they work in, region.continent, is in EMEA, Europe, or APAC, which is the Asia Pacific region. So it's creating an employee query that checks only employees that are in those two regions. Yeah. So that's not actually executing the query. That's defining the query. Yeah. And then in this second example, it's saying I want to find all the sales where the employee is in that region in this previous query, and the total is greater than 50,000. So you're able to compose queries, and using the native Groovy operator support, instead of having to use some most database libraries force you to use methods for greater than or less than. In this case, I'm using the native in operator. I'm using and. I'm using greater than to actually define my query that gets executed in the database against the database. So GORM is hugely powerful. This is not a GORM talk. I have one of those tomorrow. Shameless plug, if you want to come to that. So where I'll talk a lot more about GORM and what it can do. So if you're interested in using GORM and knowing more about GORM in your Spring Boot application, come to my talk tomorrow. I'm going to do a talk on GORM and advanced GORM and what can be done with it across different database, from MongoDB to relational databases to, and going into more detail on things like subqueries and detached criteria and so forth. So what about MongoDB? So you want to use GORM, but you're not using a relational database. You're using MongoDB in your Spring Boot app. How do you go about that? So essentially, you just change that dependency. So back to my app. I think I had edited that before, so I'll just, oops. So yeah, you just change that. Instead of using Hibernate 4, use GORM MongoDB Spring Boot. Yeah, and import that. You make sure that you've got MongoDB running, which I do here in the background. And we run my application. So as I said, GORM is multi-data store. It's not tied to relational databases. You get the same querying API, the same methods. But in the case of something like MongoDB, you get even more. Actually, I've already got some people in my MongoDB database, so let's pick those up. Fred Flintstone and Barney Rubble. But we can persist stuff to my MongoDB database, and that. So you can see it's received some connections. So yeah, this is now using MongoDB just from a change of dependency. Other than that, no actual code changes to the application. Instead, now we're persisting to MongoDB. All very, very trivial. So what do you get with GORM for MongoDB? So there's a whole bunch of stuff that GORM for MongoDB has that GORM for Hibernate doesn't have. So we have support for geospatial querying, geospatial dynamic finders. So if my person domain class, for example, had a home address field that had their location, you could say person.find by home address near some location, and it would locate using geospatial data, or find by home address within this polygon, and we'll use So there's all sorts of GeoJSON querying capability. We have native support for GeoJSON models. So inside the grails.mongodb.geo package, there's classes called Polygon, and geometry collection, and line string. Basically, GeoJSON is a specification that MongoDB implements, and you can define those. So you can have a property on your domain class that is a circle or a sphere, and you can persist that as a GeoJSON type into your MongoDB database. Another great feature is full text search. So with GORM for MongoDB, you can define a text search index on any property or collection of properties within a MongoDB domain class. And then you can call, so say, for example, I wanted to search on first name and last name. You define a text index on those two, and then you just do person.search and pass in your query, and it's got full text search, Google-like queries, without needing to introduce something like Elasticsearch or introduce something like Compass or Lucerne or a separate querying engine. It's got native to MongoDB. You also have schemaless domain models, so you can have your fixed domain models, like in that person domain class I had first name and last name. But one of the great things of MongoDB is it's schemaless, so you can store additional data. There's no fixed column row structure like in a relational database. So if you wanted to store some kind of random data within a particular person document, that's possible with MongoDB. And GORM for MongoDB has a really neat way of doing this, where you just use dynamic properties. So you say person.blah equals stuff, and it'll store that dynamic field in your domain class when it persisted. Easy, without doing anything different. GORM for MongoDB also natively uses the MongoDB aggregation pipeline for doing projections. So when I say projections, I'm talking about things like average, calculating the average, the sum, those kind of projections. The way to do that in MongoDB is to use the aggregation pipeline. And GORM for MongoDB's querying engine integrates with the MongoDB aggregation pipeline, so it works seamlessly. And another thing about GORM for MongoDB, which is also, so MongoDB is often used for massive data, massive amounts of data spanning many nodes. So one of the things, like with Hibernate, for example, is when you query for entities or from your database, every single one of those domain instances is a Java object. So if you query for 1,000 objects, those 1,000 objects have a Java, become in memory, and you run out of memory. There's various ways around this in Hibernate. There's this thing called a stateless session and a scrollable session, I think it is, or something like that. But basically, we have native support for stateless mode inside MongoDB. So you can literally query thousands of records and iterate over them, and you won't run out of memory. And there's a way to switch between stateless and stateful for a particular domain class at runtime, or declare it stateful or stateless at the declaration time, depending. Because the different use cases are stateful versus stateless. Stateful is better for write-heavy. Stateless is better for read-heavy, if that makes sense. If you're doing a lot of read operations, huge amount of data, stateless is better. But if you're doing a lot of write operations, we can batch up things and do a multi-document insert on 10 entities instead of doing insert, which you would have to do in a stateless model. Yeah. So the different modes have different use cases, but that's all integrated into GORM for MongoDB. Okay, so now, final step on your path to enlightenment with Spring Boot and Groovy is GSP. So I've already introduced one template engine, the Groovy markup template engine. So why would we need another template engine? So I'm going to talk a bit about GSP. So GSP is the view rendering engine from Grails, and it supports tag libraries, it supports XSS and double encoding prevention, layouts, templates, and views. It's mature, highly performant, robust. Views written in GSP are compiled directly into Groovy code and in an optimized way. So most calls are direct and optimized extremely fast in recent versions of Grails. And a lot of work on the performance of GSP has gone into it. So why, as I said, why would you use GSP versus Groovy templates? So Groovy templates are great if you're mainly a developer team, but GSP uses standard XML, HTML markup, which is potentially more designer friendly. So if you have your team split out in a way where you have designers that work on your templates, if they open up a bunch of Groovy code, they may not be hugely comfortable with that. But if they open up something that's HTML or that's far more comforting to those kinds of teams that have those split responsibilities. So it's mature. It's been used by Grails for years. It has development and so it's got a pre-compilation mode that doesn't use permgen at runtime, and also an extremely important feature. So Groovy templates, they do have a way to escape data and render data as unescaped, but GSP has native XSS prevention. So whenever you try and output a piece of data onto the page, it will always escape it. And it tracks the data so that it knows what's been output and what hasn't been output, and it knows if it's already been encoded. So you get double encoding prevention. Yeah? So it's impossible in GSP to get a piece of data rendered on the page that has been encoded twice. Yeah? So if you escape HTML and then escape it again, that doesn't happen. And it's a common mistake. You escaped it once, and then you pass it in, and you get escaped again. And the only way to render data on a GSP page that isn't escaped is if you explicitly use the raw method. So you say, I believe this data is safe. You call the raw method. You pass your piece of data in, and it will be allowed to be rendered. But you have to make a conscious decision in GSP to allow a particular piece of data to be rendered in an unsafe manner. Another potentially useful thing with GSP is it can use existing JSP tag libraries. So if you have a JSP tag library that you particularly want to use, there might be one out there. Or it can also use GSP tag libraries. So that's handy too. So how do you go about getting GSP into a Spring Boot app? So essentially, you add the Grails-GSP-Spring Boot as a dependency. We're currently at RC1, but the final GA is going to be out very, very soon. So it's ready. Just has to be pushed. And then you essentially, just like with the Groovy templates, you add them to source main resources templates. But instead of with the .tpl extension from before, you use .gsp. Yeah? So they go in there. So let's have a look at this in action then. Check out. OK, so now I have my application here. But instead of the Groovy templates from before, we have GSPs. So you can see I've got a home.gsp, which just renders some markup, not particularly interesting. But the list.gsp, as you can see, it's using, it's outputting the list of people, the header. It's using this date format tag, which I'll talk about in a minute, to output what the day is. It's using each to iterate over the people, or the persons in this case, and outputting so very similar to the logic and basically the flow, but obviously it's all in standard markup. And every expression here where that outputs something to the page, like for example these two expressions here, those will be automatically escaped automatically without you having. And they will never be double encoded ever. Yeah, so it's got automatic XSS prevention and double encoding prevention, and they get output there. This is what GSP looks like, and if you look at my main.gsp, just like in Grails, main.gsp gets applied to every page. So if you have a main.gsp, it gets applied to every page. Yeah. If you create another layout name, say foo.gsp, then you can provide a meta tag just like in Grails that says this is the layout I want applied. You can also use apply layout. You can use the render tag to render subtemplates. You can do all the normal Grails things for composing your views. And as you can see here, I've got my in my layout, I'm saying I want to output the head of the page that's being rendered. Over here, I want to output the body, and actually, I should probably put him here. I can output the title of the page. I could have done that in my body. So the cool thing about GSP as well is that as you can see, I've got an HTML and a head tag and over here, but I've also got that in my page that's going to be rendered. So that GSP will just take the body out, yeah, and it'll take the title out. So it kind of decorates the page rather than with Groovy templates, which you don't have those elements. So I could still open this list.gsp in like a browser or whatever, and it would still be a fully formed thing that designers can understand and so forth. It doesn't just have H1, P1 directly, whatever. So it's a fully formed page. So one thing I wanted to mention was the date format tag. So if I look at that's actually not something that's part of GSP. If I look at my Groovy code base here, you can see I've got a new class here. It's called person taglib. Yeah, and you can see that I've imported the grails.gsp.taglib annotation, and I've added @taglib and @component. @component ensures that it gets scanned. @taglib marks it as a tag library. And this is it's just called person taglib, but it probably should be called format taglib or something more appropriate. And you can see I've defined one tag called date format, which outputs using the simple date format class the format and the date to be formatted. And because I've defined this tag library in here, I can use it in my GSP views. So I can call it as a tag, like this. I'm g:\date format, yeah. And so this is calling that tag library I just showed you. I can also, just like in Grails, call it as a method, yeah. So this is one of the really neat features of GSP that makes it so readable, because one of the problems with JSP is when you want to embed output from a tag inside of an expression, you have to put the tag inside of the expression, and it starts getting really nasty. With GSP, each tag can be called as a method. Yeah, so I'm calling g.date format and passing in using named attributes a Groovy feature, and it just works. Yeah, so I can run this up if you want. Yes.
Did you define the namespace as G, or is that still?
That's the default namespace. We didn't think Spring Boot would particularly want a different. I could actually have left that out, so I could have just done that, and that would have worked as well. But the default namespace is still G, which works with GSP. I don't think that was worth changing. But you can, of course, come into I can come into the tag lib and I can say, just like in Grails, static namespace equals utils, or whatever you want to call it. And then in here, instead of doing gdate format, I would have to put utils date format. And instead of down here, g.date format, I'd have to put utils.date format. Yeah. So that whole mechanism works exactly the same as in Grails.
Does your controller change at all?
No. The controller is exactly the same. Okay.
Like the G-link tag, where you normally specify controller and actions, since we don't have the Grails.
So yeah, any Grail-specific tags are not there. G-link doesn't make sense in the Spring Boot application because there's no, I think that's coming. I think they're working on that for Spring, new version of Spring, or is anybody on the Spring team here? Aren't they working on some kind of reverse link generator in Spring or something? Yeah. Yeah, that's what I thought. So, but 4.1 has just come out. So now that those APIs are in place, there could be a tag library for GSP that utilized that created a G-link tag. But it would have to use those specific APIs from Spring 4.1, which is just out the oven, so to speak. Okay, so yeah, that is GSP and Spring Boot. So yeah, you get this easy definition of tag libraries in Groovy code, trivial to write tag libraries, elegant markup. So the majority of the really useful tags, non-Grail specific ones, are there in GSP. So geach, gwhile, gif, gelse, all the logical ones are there, as well as anything to do with rendering templates and layouts. So apply layout, grender, all those layout-related ones are all there. The only thing that is not there, as I said, is the anything Grail specific. So anything that's specific to Grails is not there. You can write your own tag libraries, as I saw, just as in Grails. And potentially with Grails 3, when we start unifying this whole thing together and Grails plugins start being updated to Grails 3, plugins that have tag libraries will be usable in Spring Boot potentially, if they're generic and so on and so forth. So we see a lot of convergence in that area. So that was my presentation. Q&A time. Yes?
Going back to your GORM section, did you have a section in your code that pointed to the configuration for the MongoDB instance?
No. So the question is there a bit of my code that pointed to the configuration for the MongoDB instance? No, I didn't have anything. If you don't, basically with Spring Boot, if you don't have anything, it just defaults to values. So I just had MongoDB running on localhost, unpassword protected, and it just picked up the default values and it just worked. But with Spring Boot, you can create an application.yaml file or an application.properties file, and normally the most typical approach is YAML. And in there, you can put your MongoDB configuration just using the standard Spring Boot way of configuring Mongo, which is in the Spring Boot documentation.
Would that work for standard Hibernate databases like Oracle or MySQL?
Yes, absolutely. So the Spring Boot documentation also has info on how to configure your data source. So the configuration model hasn't changed. It relies on how Spring Boot is configured. Yeah. So you just reference the Spring Boot docs on how to configure your data source, how to configure your MongoDB instance, and it picks up those. There's nothing that is specific to GORM in that sense. Question at the back?
If I do all that, would you turn around and say I have a full man of Grails and maybe I should use Grails?
So the question is, if you did all that, would you think I have a poor man's Grails? and I should just use Grails. No. I think that Spring Boot is compelling by itself, and that's why we're building on Spring Boot for Grails 3. I think that Grails 3 has a lot to offer in and enhancements to Spring Boot, is particularly around the plugin system. But Grails 3, we're only talking about milestones towards the end of the year. So if you and Spring Boot has really great support for things like microservices and so on. So which we're not there yet with Grails. Question, yeah?
Is unit testing domains working out of the box?
Sorry, what was that?
Unit testing
Domains.
domains.
So the question is unit testing domains out of the box? There isn't anything specific for that is part of the Spring Boot extensions for unit testing domains, but as I had a unit test there. Was it in step 2? I think it was, which tested an interaction with a GORM. Here it is, and you can see that I'm mocking the call to the list method here. So you can essentially write tests that mock out interactions with GORM automatically. You can also, because Spring Boot, it's really easy to load up the Spring Boot environment inside of a unit test. You can just write integration-style tests that load up your Spring Boot application inside your unit test, and just write tests that interact directly with your in-memory database or whatever. But there isn't anything specific provided for tests. At the back there first, I think.
What about the environment-specific configuration? Do we have this kind of thing?
So the question is, what about environment-specific configuration? So there isn't anything like Grails where you have fixed environments, like production development, like in Grails. But Spring does have a notion of profiles, I think they're called. And so it doesn't have this notion of fixed development production, but you can make up names like your own names and create specific profiles in Spring. You can have a profile for development, a profile for production, and have different configuration for different scenarios. It's just that the names aren't upfront provided like in Grails there. But anyway, that's Scott?
Do you have these examples on GitHub?
No, but I can push them to GitHub. I will. I'm going to publish all my slides to SlideShare, and at the end of it, and I'll push all the examples up as well with links. At the back. So the question is, do I have the scaffolding feature here? No, that scaffolding uses extensive Grails-specific APIs. I think you could write a scaffolding something for Spring Boot. I don't think it would be terribly trivial. I don't think it'd be terribly difficult. But because it's it's not. But I don't know of one that exists right now, unless you know. But no, that's not there yet. So is that all the questions then? One more over there. So the question is GORM compared to Spring Data. Okay, so one thing to say first of all is that GORM, in a lot of cases, uses Spring Data under the covers. So it's not GORM or Spring Data. When you're using GORM for MongoDB, you're actually using Spring Data MongoDB underneath to interact with. So it's kind of like the relationship between Grails and Spring MVC. Yeah, there's foundational stuff in Spring Data, and that's what in GORM we see Spring Data as foundational. But there are different approaches in terms of actual usage. So Spring Data is about repositories and defining interfaces and having that code generated, while the design focus on GORM is very much around the domain model and the logic existing in richer domain models. The the one you choose. And of course, Spring Data can be used with Java or Groovy. GORM is very much focused on the Groovy DSL for querying and so forth. So in Spring Data, it doesn't have dynamic finders, but it's got like, you can define an interface with just finder methods, and those get automatically implemented for you. So that's kind of similar in a way. But it's kind of statically defined lists rather than, yeah. Any other questions? Okay, I think we're done then. Thank you.